This is the single replacement and double replacement reactions lab. For the single replacement reactions, you will need your activity series, and for the double replacement reactions, you will need your solubility rules. As you work through the lab, make sure that you record each reaction on your data sheet and what actually happens in the lab. Okay guys, so this is single replacement reactions. So we're going to use our knowledge of what we've learned in class using activity series to complete these 10 reactions, and we're going to actually see what happens or predict if nothing happens, okay? So you're going to need your activity series chart. So our first reaction that we're going to look at is zinc plus sodium chloride. So zinc is Zn, sodium chloride is NaCl. Now, we're going to look at our activity series. Zinc has to be more active than sodium to kick it out. Okay, so we're going to look at our activity series. This is going to look a little bit different from the one that I used in class, but it's still the same thing. So we're looking for zinc and sodium. Zinc is right here, sodium's up here. Zinc has to be above sodium to displace it, so this is going to be no reaction. Okay, so we get no reaction. So we're going to predict and see what actually happens when we take zinc and sodium chloride. So zinc, it looks like that. So I'm going to take a piece of zinc and put it in my test tube. And then I'm going to take a squirt of sodium chloride. Okay. And let's make sure all of the zinc gets covered. We don't need an exact amount. You can tell nothing happens in this reaction. So our prediction of no reaction was actually true. Okay, so the next reaction we're going to look at, so this is single replacement reaction number 2, is going to be zinc plus magnesium nitrate. Okay, so zinc plus magnesium is Mg with a +2 charge. Nitrate is NO3 with a -1 charge. So when I go to write this, I have to crisscross. Now on single replacement reactions, we're going to use our activity series. Okay, so we're going to be looking at zinc and Mg. So magnesium's right here, Mg, and zinc is right here. So in order for it to displace it, it has to be above the magnesium. So this is going to be another no reaction. Okay, no big fantastic surprises there. So we'll take a look at what actually happens in real life. Okay, so I'm going to take another piece of zinc and I'm going to put it in my test tube. And we're taking magnesium nitrate. So magnesium nitrate is a clear solution, looks like that. And I'm going to put some squirts in my test tube and see if anything happens. Okay. So as you can tell, nothing happened by the reaction of magnesium nitrate and zinc. So our prediction was true. Okay, single replacement reaction number 3 is going to be between zinc and copper 2 sulfate. So copper is going to have a +2 charge. Sulfate is SO4 with a -2 charge. Okay, there's no need to crisscross because they're equal and opposite. So we're going to use our activity series on this, zinc and copper. So zinc is right here, and copper is way down here. So it will displace it out. So we should have some sort of reaction that goes on. So these two metals are going to switch spots, and we're going to kick out the copper. So zinc has a +2 charge always. Sulfate always has a -2 charge plus copper. Now, we're going to balance our equation. Let's make sure everything's balanced. 1 SO4, 1 SO4, 1 zinc, 1 zinc, 1 copper, 1 copper. It's balanced, okay? So we should actually get something that happens in this reaction. Okay, so I took my piece of zinc, I already put it in the test tube, and from our other labs, you know that copper 2 solution, usually copper 2 sulfate especially, is going to be blue, Okay, so I'm going to put some healthy squirts, make sure that we get everything covered so we can see the reaction actually happening. Okay, so you can tell that the zinc is reacting and you're getting this brown metal on the outside of it, so it's plating out the copper. So if I let this sit here for a while, it'll get more and more obvious. But remember, one of the things, evidence of a chemical reaction is going to be a change of color. Okay, so you can see the copper is beginning to plate out. If I can get there's a really good side that has a lot of copper, but it doesn't want to. Doesn't want to change. There we go. Here we got a good view. So you see the copper? It's all plating out. Okay, so this is going to be single replacement reaction number 4. So we're going to be taking zinc and we're going to mix it with silver nitrate. Okay, so zinc is Zn, silver is Ag with a +1 charge, nitrate is NO3 with a -1 charge. Okay, no need to crisscross because they're equal and opposite charges. So we're going to look at our activity series. Zinc and silver. So zinc is way up here, silver's right here, so it's going to kick it out. Okay, so these two things are going to switch places, and so we get Zn with a +2 charge, NO3 with a -1 charge, and we have to crisscross because they have opposite. They don't have the same charges. Okay, plus Ag. So let's balance this. We have 2 nitrates on this side. We need to put 2 nitrates on this side. 2 Ags, 2 Ags, 1 Zn, 1 Zn. It should be balanced. Okay, so we'll come back and look at what it actually looks like in real life. Okay, so I put my piece of zinc in the test tube and we're gonna add some silver nitrate. So silver nitrate looks clear. Okay, so add a few squirts of this. If you can tell, starting to plate out some silver on the zinc. Okay, so that is the reaction of zinc and silver nitrate. Okay, so single replacement reaction number 5 says that we're going to take magnesium and we're going to mix it with copper 2 sulfate. So magnesium is Mg. Copper 2 sulfate, copper is Cu with a +2 charge. Sulfate is SO4 with a -2 charge. Okay, now we got to use we have to use our activity series to determine if there's going to be a reaction or not. So magnesium's right here, and copper is way down here. So it's going to kick it out. Okay. So those two are going to switch spots, and we're going to have Mg with +2 charge, SO4 with a -2 charge. There's no need to crisscross because they're equal and opposite. And we're going to kick out some copper. Okay, balancing 1 Mg, 1 Mg, 1 Cu, 1 Cu, 1 SO4, 1 SO4, so it should be balanced. Now looking at what Mg looks like in real life, magnesium, we're going to take a little piece of magnesium, okay, so put it in our test tube, looks like that, and we're going to react it with copper 2 sulfate. So our copper 2 sulfate is the blue solution, and we're going to stand it up, and we're going to add to it. So I'm going to zoom in a little bit, if I can zoom in. Okay, so there's a reaction that goes on. You can tell that there's starting to be some brown form on the magnesium. Okay, so that's the copper metal that's plating out on it. And that's our reaction number 5. Okay, so this is going to be single replacement reaction number 6. We're going to take some magnesium and we're going to mix it with some sodium chloride. So symbol for magnesium is Mg. Sodium chloride's Na with a +1 charge. Chloride's Cl with a -1 charge. Now we're going to use our activity series to determine if we're going to have a reaction or not. So we're going to look at Mg and Na. So magnesium's right here and sodium is above it. So the magnesium will not kick out the sodium. Remember, it's got to be a more active metal. Okay? So we're just going to write no reaction. Okay? We're not going to get excited about that. We'll come back and confirm to make sure that that is the correct reaction. Thanks. Okay, so put some magnesium in a test tube, and we're looking at magnesium plus sodium chloride. So our sodium chloride solution is clear. Okay, so I'm going to put a few squirts in it just to make sure something's not going to happen. Okay, so if I'm looking at it, nothing happens. So our thought of no reaction is actually true. Thanks. And we'll come back and do single replacement reaction number 7. Okay, so in single replacement reaction number 7, we're going to be taking magnesium plus silver nitrate. So magnesium is Mg, and silver nitrate is Ag with a +1 charge, NO3 with a -1 charge. They're equal and opposite charges, so there's no need to crisscross. Okay, so we're going to use our activity series to see if Mg is more active than Ag. Okay, magnesium's all the way up here, and silver's all the way down here. So it's going to kick it out. Okay, so we get magnesium has a +2 charge. Nitrate always has a -1 charge. And we crisscross. The 2 goes down here, the 1 goes there. Plus silver. Okay, now we're going to balance. You got 2 nitrates on this side. We need to put 2 nitrates on this side. 2 Ags, 2 Ags. 1 Mg, 1 Mg. It should be balanced. So we'll come back and look at the actual reaction in real life. I've already put my piece of magnesium in my test tube. And this is going to be single replacement reaction number 7. So we're taking magnesium plus silver nitrate. Remember, our silver nitrate is a clear solution. Okay, so it's a clear solution. And we're just going to add a couple squirts to this, see if something happens. Okay. So we'll zoom in just a little bit, as we can tell that something is happening. The silver is being plated out onto the magnesium. Okay. Okay, so this is going to be single replacement reaction number 8. It says we're going to mix solid copper with silver nitrate. So copper plus silver nitrate. Silver is Ag with a +1 charge. Nitrate's NO3 with a -1 charge. Okay, so we're going to have to use our activity series to determine if copper is more active than silver. Okay, so we look at our activity series. Copper is down here and silver is below it. Okay, so it will kick it out. So they'll switch spots, and we're going to be using copper too. So this is going to be copper with a +2 charge. NO3 has a -1 charge. And then plus silver. Okay. There's 2 NO3s on this side, so we need 2 NO3s on this side, 2 Ags, 2 Ags. It would work the same way if you had copper 1, but most likely it's going to be copper 2 whenever we do this type of reaction. Okay, so I'm going to take a test tube and put some copper in it, and we'll be right back. So we can look and see what copper looks like. Okay, so I'm going to take a couple pieces of metal, copper metal, and put them in my test tube. And I'm going to take some silver nitrate. So our silver nitrate is this clear solution. Okay. And I'm going to take a little squirt. Take a little more so we can actually see what really happens. Okay, so as you can tell, the copper metal doesn't look like it's copper metal anymore. Okay, the silver is plating out onto the metal. Okay, this is actually a really cool experiment. If you take a big long copper wire and you leave it in the silver nitrate for an extended period of time, you get these huge silver crystals that happen. So this is one of my favorite reactions. Okay, so this is single replacement reaction number 9. It says we're going to take solid copper, and I'm going to react it with sodium chloride. So sodium is Na with a +1 charge, chloride is Cl with a -1 charge. No need to crisscross because they're equal and opposite charges. So I'm going to look at my activity series, and copper is down here, and sodium is way up here. So that copper is not going to kick it out, so there's going to be no reaction. Okay, so we'll come back in just a second just to verify that there's no reaction in real life. This is reaction number 9 for single replacement. I took some copper metal, I already put it in my test tube, and I'm going to take some sodium chloride. Sodium chloride is a clear solution. Okay, so I'm going to add a couple squirts to my test tube. Make sure I cover all the metal. Let's see if anything happens. So as you can tell, nothing happens. Okay, so our hypothesis was right that there was going to be no reaction with copper and sodium chloride. So this is going to be single replacement reaction number 10. It says we're going to take solid copper, so Cu, and we're going to react it with magnesium nitrate. So magnesium is Mg with a +2 charge. Nitrate's NO3 with a -1 charge. So they're not equal and opposite, so I'm going to have to crisscross. Okay? So we're going to look and see if copper is going to displace the magnesium. Okay? So copper is down here, and magnesium is way up here. So it is not a more active metal, so there should be no reaction that occurs. And we'll come back and confirm that in real life. Just copper metal in my test tube, and I'm going to take a couple squirts of magnesium nitrate. It's a clear solution. We predicted that nothing will happen, so we should get nothing that happens. Okay. And if I look at what actually happens, the copper looks unchanged. Okay, so our hypothesis of no reaction was actually true. Okay, when we start doing these double replacement reactions, we're going to have to be using our solubility rules. So the first one says we're going to mix sodium carbonate and 10 drops of concentrated hydrochloric acid. Okay, so sodium carbonate, sodium is Na with a +1. Carbonate is CO3 with a -2 charge. We have to crisscross. Plus hydrochloric acid. Remember the prefix hydro means there's 2 elements, so it's HCl. Now, in a double replacement reaction, we take the outer 2 ions and put them together. Like that. And we're going to take the inner 2 ions and put them together. So we get Na +1 charge, Cl with a -1 charge. Plus I'm going to take the H and the CO3 and put it together. So hydrogen always has a +1 charge, and carbonate always has a -2 charge. We're going to crisscross. Now remember, we're not bringing subscripts from this side to this side. Those come from the crisscross. Now, whenever we have H2CO3, that's carbonic acid. So if we think about carbonic acid, we're going to be talking about like our sodas and our carbonated beverages. So what happens is it's actually going to look like this. NaCl plus CO2 plus water. Okay, so this carbonic acid breaks down. Now, When we go and do these double replacement reactions, we need to make sure we do our solubility rules. Okay? Okay, so let's make sure it's balanced first. So I have two NAs on this side, need two NAs on this side, two CLs, two CLs, two H's, two H's, three O's, one C, one C, so it's balanced. Now, we have to use our solubility rules, so let's go through and do our solubility rules. Okay, sodium carbonate. All carbonates are insoluble except for NH4 and group 1 metals. So sodium is in group 1, so it's soluble. So we write AQ. Acids are always soluble. Sodium chloride. All chlorides are soluble except for silver, mercury, lead. So this is going to be soluble. CO2 is a gas, and it's going to produce liquid water. Okay? So there's a few examples like this in the actual, in the lab further down. So anytime we get H2CO3, we're going to break it down to CO2 and water. Okay, so what we're going to do for double replacement reaction number 1, we're going to take a healthy squirt of sodium carbonate. Okay, it looks like this is a clear solution. Okay, and it says to add 10 drops of concentrated hydrochloric acid. Okay, so we should see some sort of bubbles going on. So see the bubbles that went on. Sorry, I couldn't get it up to the camera fast enough. So let's do a little more so we can actually see it happen. And I'm gonna add a little more hydrochloric acid. I'm trying to move the camera up real quick. See it fizzed? Okay, so there's evidence of a chemical reaction. That's called effervescence. Okay, so the next reaction we're going to look at, so this is double replacement reaction number 2. It says we're going to mix sodium hydroxide. So sodium is Na with a +1 charge. Hydroxide is OH. They're equal and opposite, so we don't have to crisscross. Plus hydrochloric acid, which is HCl. We did that from the last problem. Now, this is going to be an acid-base reaction or a neutralization reaction, so that always produces a salt and water. Okay, so we take the Na and the Cl and we're going to put it together. And an H and an OH together gives you water. Okay, so if we're going to balance this, we have two H's, one O, one O, one Cl, one Cl, one Na, one Na. So it's going to be balanced. If you want to write this as HOH like we did in class, you're more than welcome to do that also to help you balance. Okay, now we got to do our solubility rules. So I'm going to go back to my solubility rules, and it says that all compounds containing hydroxide are insoluble except for group 1, calcium, strontium, barium. Okay, sodium is in group 1, so it's soluble. All acids are soluble. Sodium chloride, all chlorides are soluble except for silver, mercury, lead. And then water is going to be liquid. Okay. Okay, so the lab procedure says mix sodium hydroxide and hydrochloric acid. Okay, so this is double replacement reaction number 2. So my sodium hydroxide's clear. We just got to put some healthy squirts. And hydrochloric acid. Okay, so did you see the the bubbles going on? So you're going to have some effervescence going on. Now, if I fill the test tube, it's hot, okay? So this is going to be an exothermic reaction, okay? That's another evidence of a chemical reaction has occurred. So maybe we got this wrong. Maybe it isn't liquid water. Maybe it's steam that's produced, okay? So let's change that to a gas, just to make sure we got it right. Okay, so this is going to be double replacement reaction number 3. It says we're going to take potassium chloride. So potassium's K with a +1 charge, chloride Cl with a -1 charge. No need to crisscross because they're equal and opposite. Plus silver nitrate. So silver is Ag with a +1 charge. NO3 is nitrate with a -1 charge. No need to crisscross. So when we go into our double replacement reaction, we're going to take the outer 2 ions and put them together. So KNO3, this has a +1 charge, this has a -1 charge, and then Ag and Cl. Make sure that you always write the metal or the positive ion first. Okay, so no need to crisscross. It should be balanced because we've got one of everything. Now let's go do our solubility rules. So all compounds containing Cl are soluble except for silver, mercury, lead. It does not fall into an exception, so it's soluble. All compounds containing NO3 are soluble. All compounds containing NO3 are soluble. Okay? All compounds containing Cl are soluble except for silver, mercury, and lead. So it falls into an exception, so we should get a precipitate out of this. Okay? So remember what a precipitate is it's an insoluble solid that happens whenever you mix 2 liquids together. We'll come back and see what this looks like in real life. So I'm going to take the KCl is in this little beaker, mini beaker. Put a couple squirts in there. And then I'm going to take my silver nitrate. So my silver nitrate, remember, was clear. Hopefully I don't run out. Okay. So as you can see, it formed a white precipitate. It's chalky looking, okay? And there's a change in consistency, so that's evidence of a chemical reaction. Okay, so this is going to be double replacement reaction number 4. So it says to mix silver nitrate and calcium chloride. So silver nitrate's AgNO3. It's a +1 charge, and that has a -1 charge. And we're mixing it with calcium chloride. So calcium is Ca with a +2 charge. Chloride is Cl with a -1 charge. So we crisscross like that. Okay, in a double replacement reaction, we take the outer 2 ions and put them together. So we get Ag with a +1 charge, Cl with a -1 charge. No need to crisscross because they're equal and opposite. Plus, take the inner 2 ions and put them together. Calcium has a +2 charge, and nitrate has a -1 charge. So it should look like that. Now, we need to balance it. Did I balance the last one? Yeah, it was balanced. Okay, just making sure. Okay, so 2 Cls. I need to get 2 Cls on this side, 2 Ags, 2 Ags, 2 NO3s, 2 NO3s, 1 Ca, 1 Ca. It's balanced. Now we need to go do our solubility rules. All compounds containing nitrate are soluble. All compounds containing Cl are soluble except for silver, mercury, lead. So this is soluble. All compounds containing chloride are soluble except for silver, mercury, lead. This is silver, so you should get a precipitate there. All compounds containing NO3 are soluble, so it's AQ like that. So we'll come back and we'll look at what that looks like in real life. Okay, so I'm going to take some silver nitrate. Squirt with that. And then I'm going to take some calcium chloride. So calcium chloride is a clear solution. Okay, I'm going to put a nice squirt of that. And like the last problem we did, you get a white precipitate that forms. Okay? So that's evidence of a chemical reaction right there. Okay, so this is double replacement reaction number 5. Now, number 5, it says mix lead 2 nitrates. So lead is Pb, has a +2 charge. Nitrate's NO3 with a -1 charge. We crisscross, it looks like that. Okay, and we're gonna mix it with potassium iodide. Okay, so potassium is K. The +1 charge, iodide is -1 charge. No need to crisscross because they're equal and opposite. So on double replacement reactions, we take the outer two ions and put them together. So PB is still going to have a +2 charge. Iodide is still going to have a -1 charge. You have to crisscross. Okay, just like we did in class. And then we're going to take the inner two ions and put them together. Okay, we're going to take the K, has a +1 charge, and NO3 nitrate has a -1 charge. No need to crisscross. Notice I didn't bring the 2 over. The 2 comes from the crisscross over here, so we don't move subscripts over the arrow. So let's start balancing this. 2 I's on this side, 2 I's on this side. 2 K's, 2 K's, 2 NO3s, 2 NO3s, 1 PB, 1 PB. It's balanced. Now we need to go through and do our solubility rules. All compounds containing nitrate are soluble. All compounds containing I are soluble except for silver, mercury, lead. So this is soluble. All compounds containing iodide are soluble except for silver, mercury, lead. So this is going to be insoluble. And all compounds containing NO3 are soluble. Okay, so a lot of times when you have silver, mercury, lead involved, they're going to be insoluble and they're going to form a precipitate. So we'll come back and see this in real life. Okay, so we're going to take our lead nitrate is a clear solution. I'm going to put it in our test tube. Nice squirt, and then we're going to take our Ki, or potassium iodide. We're going to put a nice squirt in there. And we get a nice yellow precipitate. Okay, so this is one of the cooler reactions that happens. So this is your lead iodide, it looks like. Okay, so this is going to be double replacement reaction number 6. So it says we're going to take sodium sulfate. So sodium is Na with a +1 charge. Sulfate is SO4 with a -2 charge. And we crisscross. And we're going to mix it with barium chloride. So barium is Ba. Chloride is Cl with a -1 charge. We crisscross. Looks like that. So when we do our double replacement reaction, we're going to take the outer two ions and put them together, and the inner two ions and put them together. Okay, so sodium +1 charge, chloride -1 charge, plus barium has a +2 charge, and sulfate has a -2 charge, so they're equal and opposite charges. Now if we're going to balance this, you have 2 Cl's on this side, I need 2 Cl's on this side, 2 NA's, 2 NA's, 1 SO4, 1 SO4, 1 Ba, 1 Ba. It's balanced. So we'll come back and see this in real life. Oh, we need to do our solubility rules. Sorry. Solubility rules. All sulfates are soluble except for compounds of strontium, barium, mercury, and lead. So this does not fall into an exception, so this is soluble over here. Barium chloride. All chlorides are soluble except for silver, mercury, lead. That doesn't fall into an exception. So it's soluble. All compounds containing chloride are soluble except for silver, mercury, lead. So it's soluble. And all compounds containing SO4 sulfate are soluble except for strontium, barium, mercury, and lead. So it falls into an exception, so it's going to form a precipitate. So we'll come back and we'll look at this in real life. Okay, so I'm going to take my sodium sulfate solution. I'm going to put me a nice squirt in the test tube, and then I'm going to take my barium chloride solution, and I'm going to put a nice squirt. Okay. So it formed a milky white precipitate. Okay, they're both clear solutions, and then when you mix them together, you get a white precipitate. Okay, so we're looking at double replacement reaction number 7. It says, place a small amount of solid calcium carbonate and 5 drops of hydrochloric acid. Okay, so calcium carbonate. Calcium is Ca with a +2 charge. Carbonate is CO3 with a -2 charge. Hydrochloric acid is HCl. Okay, so this is going to be one of those ones like we did at the beginning, where the carbonic acid is going to break down into CO2 and water. Okay, so we're going to take the outer two ions and put them together. Okay, so we'll go to crisscross, H and CO3. We're going to put those together. So the H has a +1 charge, the CO3 has a -2 charge. So we'll get that. Now remember I said that this is going to break down into CO2 and water. Okay, and we need to make sure it's going to balance. Okay, so we got 2 Cl's on this side, we need 2 Cl's on this side, 2 H's, 2 H's, 3 O's, 3 O's, 1 C, 1 C, 1 Ca, 1 Ca, and it's balanced. Okay, we're going to do our solubility rules. So it says we're going to take solid calcium carbonate, so we're going to make that a solid. Hydrochloric acid is always aqueous. All chlorides are soluble except for silver, mercury, lead. So that's soluble, and we already have those states right there. Okay, so we'll come back and look at this in real life. So this is double reaction. This is double replacement reaction number 7. So we're going to take calcium carbonate, which is solid. It looks like this. And it says that we're going to place 5 drops of dilute hydrochloric acid. So we're just going to put a little bit of hydrochloric acid in here. You can see that it's bubbling and fizzing. So I'm going to add a little more just so we can see the rest of it happen. So we get some effervescence going on. Not really getting hotter. Maybe a little bit hotter, but so we get some effervescence going on. Okay, this is double replacement reaction number 8. So we'll be taking sodium bicarbonate or sodium hydrogen carbonate. So sodium is Na with a +1 charge. Bicarbonate is HCO3 with a -1 charge. And it says we're going to react it with hydrochloric acid. Okay, so anytime I'm reacting with a bicarbonate or a carbonate, we're going to expect that there's bubbles produced, okay? So it's going to do a lot like the last reaction. Okay, so we're going to take the outer 2 ions and put them together. So Na has a +1 charge, Cl has a -1 charge. And then I'm going to take the H and the HCO3. Okay, so that's going to give me H2CO3. Okay, that's a little tricky one, so when they combine, you get that. Okay, now, anytime I get H2CO3, that's going to break down further. It's going to break down to water, carbon dioxide. Okay, and we're going to go to this side. We're going to make sure everything's going to balance out. Okay, so we got 1 Cl, 1 Cl, 2 H's, 2 H's, 3 O's, 3 O's, 1 Na, 1 Na, so it should be balanced. Bicarbonate. I would say it's going to follow the same rules as carbonates. So all bicarbonates are insoluble except for group 1 metals and NH4. So this is going to be soluble. All acids are soluble. NaCl, all chlorides are soluble except for silver, mercury, lead. So this is going to be soluble, like that. So we'll come back and we'll see it in real life. Okay, so back in real life, this is going to be double replacement reaction number 8. So I'm going to take sodium bicarbonate and I squirt. Or you can use the, which is just baking soda. You can use solid baking soda. It'll work the same way. And I'm going to take a few drops of hydrochloric acid. Okay. Okay, it fizzed. Let's see if we can see a little bit better. Okay, so there were bubbles involved. It's really hard whenever you're videotaping this stuff for it to from this angle, so there was bubbles. Sorry if I didn't get that one too well. Okay, this is going to be double replacement reaction number 9. So it says we're going to take barium chloride. So barium is Ba with a +2 charge. Chloride is Cl with a -1 charge. We crisscross, it looks like that. And I'm going to react it with sulfuric acid. So sulfuric acid is H2SO4. Okay, so we're going to take the outer 2 ions and put them together. So Ba has a +2 charge. SO4 has a -2 charge. Okay, no need to crisscross because they're equal and opposite. Plus, it's going to form HCl. Okay, okay, and that has a +1, that has a -1 charge. Okay, our solubility rules. Barium chloride. All chlorides are soluble except for silver, mercury, lead. So this is going to be soluble. All acids are soluble. All SO4 compounds containing SO4 are soluble except for strontium, barium, mercury, or lead. So this is going to be insoluble. And HCl, all chlorides are soluble except for silver, mercury, and lead. Okay, and let's balance it. So we got 2 H's and 2 Cl's. So I'm just going to double right there. 1 SO4, 1 SO4, 1 Ba, 1 Ba. So it should be balanced. We'll come back and see it in real life. So we're looking at barium chloride, so it's a clear solution. I'm going to take a squirt of that. And get a little more in my test tube. And I'm going to take some sulfuric acid. And as you can tell, that a white precipitate was formed. Okay, so a milky white precipitates formed. Okay, so this is going to be double replacement reactions number 10. So we're going to take sodium chloride, which is Na, +1 charge, chloride, -1 charge. And I'm going to react it with silver nitrate. So silver is Ag with a +1 charge. Nitrate is NO3 with a -1 charge. Okay, so outer 2 ions, we're going to put them together. So Na with a +1 charge, NO3 with a -1 charge. And I'm putting the inner 2 ions together. So silver, the +1 charge, and Cl with a -1 charge. It should all be balanced because 1 Na, 1 Na, 1 Cl, 1 Cl, 1 Ag, 1 Ag, 1 NO3, 1 NO3. Solubility rules. All chlorides are soluble except for silver, mercury, lead. This is soluble. All nitrates are soluble. All nitrates are soluble. And all compounds containing chloride are soluble except for silver, mercury, and lead. So this falls into the exception. So it is solid. So it's going to form a precipitate. So we'll come back and see it. So this is going to be double replacement reaction number 10. So I'm going to take a squirt of sodium chloride. And I'm going to take a squirt of silver nitrate. Okay. So what you get is a nice precipitate that forms. Okay. So our silver nitrate was clear and our sodium chloride was clear. So when you mix 2 soluble liquids together and get an insoluble solid, you form a precipitate. Remember that if bubbles are formed, that's called effervescence. If the reaction feels cooler, that's called endothermic reaction, and if it feels hotter, that's going to be exothermic reaction because it's releasing heat. So this has been your single replacement and double replacement reactions. Make sure you work through the worksheet with the video as I go, and have a good night.